Today we're going to talk about operations on radicals, and it's not really going to matter to me that much if you use a calculator or not, even though it does say no calculator on there. As we take a look here at our first example, it says simplify this expression fully. And just to go back to what we were talking about in Algebra 1, what we may have called this in Algebra 1 is we called it combining like terms. When we combine like terms, what we do is we add or subtract the coefficients on each term with the same variable. So that means if we have a term with an x in it, then we can combine it with another term that only has x in it. Or it could be a y, or it could be an x squared. And then the thing is once we know how to do this with something like we did in Algebra 1, with our example above, then we can apply this same idea to radicals, which, by the way, if you don't like the name radicals, you can also call it a square root. If we go back and look at the example, what we see in this example is that we have a 9x squared, and as we scan through this expression here, it also happens that we've got a 3x squared. In fact, it's minus 3x squared. Those two terms are like terms because they both have x squareds in them. We actually have a like term of 6y, and 6y is the term, and then what's alike with that is the 14y, because both of those only have y's in them. And then it just so happens that our constant of 2 doesn't have anything alike. But if we combine like terms, what we're going to do is we're going to add or subtract the coefficients. So if I look at the blues, 9x squared minus 3x squared is 6x squared. 6y plus 14y. We add the 6 and the 14 together to get 20y. And we didn't do anything with the 2, so we're just going to tack it there on the end. We want to keep it as part of our expression because we want to keep everything in balance. But again, what we do is we add the coefficients and then we keep the variable. It's going to be the same thing when we do the square roots, when we do the radicals. We're going to add or subtract the coefficients and we're going to keep the square root the same. So if we look at example 2, it says simplify the following expressions fully. Well, what's alike in this particular case? Well, negative 2 square root of 5. There's another place where there's a square root of 5. Here. Not to mention that we also have 6 square root of 3. And over here at the end, we've got the square root of 3. Those both have the square roots of 3's, which are sometimes pronounced as radical 3. By the way, do you know what the number in front of the square root of 3 is on this last term? And it is a 1. So now that we know that, we can finish this problem. Negative 2 square root of 5 plus 5 square root of 5 is 3 square root of 5. Negative 2 plus 5. The numbers out in front are what we're adding. We're leaving the square root part alone. Plus 6 radical 3 minus 1 radical 3 is 5 square root of 3. 6 minus 1 is 5. That's where the number came from out in front. And then we leave the radical as it is. We don't change that square root. If we look at letter B, got a little bit ahead of myself, but we'll be okay. On this particular problem, what we have to do is we have to distribute. And when we distribute, we're going to multiply 2 times the square root of 6 But when we distribute, we're going to multiply the numbers outside. This was like 2 times 1 to give us the 2. So over here, this is going to be 2 times 4 is 8, square root of 11. Again, we multiply the numbers outside of the square root. And then at the end, we have the plus square root of 11. Well, you told me just a minute ago that the number in front of something when it's not written is a 1. And as we take a look at this, we don't have all 3 of them like terms, but we do have 2 like terms right there. So the 2 square root of 6 isn't going to change. But we can combine like terms on these final 2 pieces here. Negative 8 square root of 11 plus 1 square root of 11 is negative 7 square root of 11. Negative 8 plus 1 gives us that negative 7. In this case, then we're subtracting that. The thing about square roots in these problems is that we need to be able to simplify the radicals, or we have to be able to simplify the radicals to be able to know if we even have like terms. So that gets us back to an old topic that we've talked about twice before during the school year. But we're going to make a factor tree. Some of you like to look for the biggest perfect square that goes into there. Whichever way is your method, I'm going to make the factor tree. I did 5 times 10 for 50. And 10 is 5 times 2. And what we're looking for is we're looking for 2 of the same value to take out 1. So 2 of the same value to take out 1 is going to be 5 square root of 2. And we still have in our problem a minus 4 square root of 2. But now that we simplified the square root of 50, we see that they really are like terms. They both have a square root of 2 in them. And when we have like terms, we can subtract, in this case, the coefficients. 5 minus 4 is 1 square root of 2. And the thing is, you can write the 1, or you don't have to. Either answer is fine with me. I'm not going to mark it wrong if you write the 1, in case you're interested about that. So again, to simplify, the thing is, when we add or subtract, radicals, we simply treat it, the radical, so I wish I would have written that a little bit better. We simply treat the radical like a variable. So this means that we add or subtract the coefficients when we've got a square root, and we keep the radical. We did the same thing on our very first example. When we had the x squared, we added or subtracted, then we kept the x squared. But as you saw, because I got a little bit ahead of myself, we can multiply and divide with radicals. And the thing about multiplying and dividing is when we multiply or divide radicals, we're not only going to deal with the coefficients, but we are going to deal with their radicands, the numbers underneath the radical. It's R-A-D-I-C-A-N-D-S. R-A-D-I-C-A-N-D-S. Again, the radicand is the value that's underneath the square root symbol. And when we multiply or divide, not only do we multiply the coefficients, but we also multiply the radicals. So for instance, on letter A, we're going to take 6 times 2. Those are both coefficients. 6 times 2 is 12. And then we're going to take the square root of 10 times the square root of 3. 10 times 3 is 30. Notice that we still have that square root symbol in there. Now the thing is, when we multiply these together, we need to check. Can we simplify the square root of 30? And the answer is going to be no on this one, so if you don't want to write down what I'm going to write down next, that is the answer, 12 square root of 30. But 30 is 3 times 10 and 2 times 5. So this is 3 times 2 times 5. We don't have two of the same value to take out 1. So again, 12 square root of 30 is all we can do on that one. But it's not always the case. If we look at letter B, again, we multiply the coefficients. Negative 2 times 10 is negative 20. And square root of 8 times square root of 5 is square root of 40. Once we multiply the numbers, once we multiply the square roots, we need to check. Can we break down, in this case, the 40? And this one's going to work. We can break it down a little bit more. 40 is 4 times 10. You could have done 8 times 5. You could have done 2 times 20. And then 4 is 2 times 2. And 10 is 2 times 5. And what we're looking for is we're looking for 2 of the same value to take out 1. So we're going to take out a 2 here. What we have left underneath the radical, also known as the radicand, is 2 times 5, which is 10. But don't forget that originally we had that negative 20. This is negative 20 times 2. And negative 20 times 2 is negative 40 square root of 10. Letter C. I probably chumped you on space. But if you can, what you might want to do is above that problem, start the process so that you have enough space. But as we take a look at this one, it's a binomial times a binomial. Binomial, 2 terms. And what we're going to use is we're going to use the double distributive property, or we're going to use FOIL, whichever one you learned in Algebra 1. In other words, we're going to take the square root of 8, we're going to multiply it by these 2 terms, and then we're going to take 3 and multiply it by both those terms. When we multiply, square root of 8 times square root of 2 times square root of 16. Square root of 8 times 4. So one of those terms has a square root in it, one of them does not have a square root in it. This is going to be minus 4 square root of 8. So we kept the number that didn't have a radical outside of it, and then we kept the square root. It was positive square root of 8 times negative 4, and that's why I'm subtracting. The next part, 3 times the square root of 2. Same idea. No radical, it stays outside of a radical. And then we've got the square root. And then the last, 3 times 4 is 12. In fact, it's positive 3 times negative 4, which is negative 12. And now we can go from there. But we need to simplify. Wherever we can simplify, we need to simplify. We need to look for like terms. But hopefully on this first step here, you know that the square root of 16 is 4. When we go to our next term, 4 square root of 8, we can simplify the square root of 8. It's 4 times 2, and 2 and 2. And what we're looking for is we're looking for 2 of the same value to take out 1. So the square root of 8 is going to be 2 square root of 2. Notice that above here, we still had minus 4. What we're going to do is we're going to take that value. It was minus 4 times the square root of 8. Once we simplified the square root of 8 to 2 square root of 2, and now what we have on this to finish this term in particular is it's going to be minus 8 square root of 2. 4 times 2 is 8. And let's bring down this 4 as well, so that we have 4 minus 8 radical 2 to line it all up. If there's any good news, the next two terms can't be simplified. So now what we still have from our problem is we have plus 3 square root of 2 minus 12. And then when we take a look at this, to finish this problem, what we need to do is we need to combine like terms. We have 4 minus 12. And 4 minus 12 is negative 8. We have negative 8 square root of 2 plus 3 square root of 2. We add the coefficients, or in this case subtract. Negative 8 plus 3 is negative 5 square root of 2. So sorry, I don't think I left enough space on that one. But luckily our last one here on this particular page is not as long. We've been dealing with the multiplication on A, B, and C, but here comes a division problem. And when we divide, what's going to happen is we're going to divide these two numbers. And then we're going to divide these two numbers. So when we divide, 12 divided by 4, we get 3. When we divide, the square root of 75 divided by 5, we get 15. Again, that is the answer, but you do want to check. 15 is 3 times 5. We do not have 2 of the same value to take out 1. So 3 square root of 15 is our answer. As we flip our paper over, kind of pulling it all together, I did not do a good job on leaving myself enough space. I hope that I left you enough space. But we're going to simplify each expression. So we've got the add, subtract, multiply, and divide in here. And follow the order of operations, which means that you have to do the grouping symbols first, the parentheses. And then grouping symbols, exponents, multiply, divide, add, subtract is what it is. Some of you learned PEMDAS if you're wondering what I'm talking about. But when we take a look at this particular problem, start by multiplying those two together. So it's 4 times 6 is 24. 2 times 5 is 10. We didn't do anything with our 5 square root of 10, and I need a negative in front of it, and I'm never going to get it there. Try one more. Negative 5 square root of 10 plus 24 square root of 10 when we multiply. And what we see is that we have like terms. We've got the square root of 10 in both of those terms. So we're going to add or subtract the coefficients. Negative 5 plus 24 gives us 19 square root of 10. Letter B. Same kind of thing. First thing that I notice in here is that we have parentheses. There's a grouping symbol. We're going to start with this. I'll do better on my space. So it's 19 square root of 13 minus 11 square root of 6. And then here, it's going to be plus the square root of 6. We multiply those two together. And even so, I'm tight on space. But plus the square root of 13. Just a reminder once again, when there's no number written in front of the square root, it's a 1. No number written in front of the square root, it's a 1. Then what we want to do is we want to identify what are the like terms. Well, 19 square root of 13 and 1 square root of 13, 1 square root of 13 are like terms. And we add the coefficients. 19 plus 1 is 20. Square root of 13. Our other terms here? Sure. Are 11, negative 11 radical 6 plus 1 radical 6. Both of those have the square root of 6 in them. Negative 11 plus 1 is minus 10. As we get close to finishing, letter C looks probably a little bit more complicated than it is, but I am going to take it step by step. And what seems complicated in this is that there's a fraction in there. So when we start on part C, I'm going to start with just the top of the fraction. 6 times 3 is 18. Square root of 14 times square root of 2 is square root of 28. Not going to change this. Not going to change that. And you can multitask. I'm going to do it a step at a time. All that I did is I looked at the top of the fraction. Secondly, 18 divided by negative 9 is negative 2. 28 divided by 7 is 4. And then we have square root of 8, square root of 2. So we divided. We divided the coefficients. The 18 divided by negative 9, 28 divided by 7. Well, then we can ask ourselves, do we know what the square root of 4 is? And you probably do. Square root of 4 is 2. And now we can start multitasking. We've simplified that first term mostly. I'll put in the negative 4 in a minute. You can work ahead of me. But here's the square root of 8 again. We've even done it once today. This is 4 times 2. And 2 and 2. And what we're looking at here is we need 2 of the same to take out 1. 2 of the same to take out 1. So the square root of 8 is 2 square root of 2. And if we go back and we look at our red, sorry, not the red, but also known as blue, negative 2 times 2, it's negative 4. So now we've got negative 4 plus 2 square root of 2. And this last term is minus the square root of 2. It's this one right there. And once again, a reminder, when there's no number in front of the square root, it's a 1. And now what we can do is we can finish this problem. And our only like terms are the green and the red terms. Negative 4, not going to change. But 2 minus 1, 2 minus 1 is 1, square root of 2. And you can choose to write the 1 in front of that red square root of 2, or you don't have to write the 1 in front of the square root of 2. It doesn't make any difference. But 2 minus 1 does equal 1, so that's where it comes from. If you need me to scroll back up, I kind of went fast at the end. So to finish, when we take a look at these expressions, it looks like there's nothing in common on letter D. Don't forget your simplifying techniques. When we look at the square root of 24, it's 4 times 6, which is 2 times 2, and 2 times 3. And what we need are 2 of the same value to take out 1. And we've got 2 2's here. So the square root of 24 becomes 2. We've got 2 singles. 2 times 3 is 6. Well, our middle term, 6 square root of 3, 3 is just 1 times 3, so we can't do anything to that. So we've got 6 radical 3. When we look at the square root of 27, square root of 27 is 9 times 3. We can break down the 9 into 3 times 3. And then what we need are 2 of the same to take out 1. And we've got 2 3's this time. So this is going to be 3, radical 3. And notice the sign in front of the 27. We're subtracting, so I'm still subtracting. And then when we look at this particular part, the red and the pinkish purple both have the square roots of 3 in them. So we can simplify there. The 2 square root of 6, it's not going to change. It is not alike with anything else. But the 6 square root of 3 minus the 3 square root of 3 leaves us with 3 square root of 3. 6 minus 3 is 3, and then we still have the square root of 3.